Okay, now let's do a single stage calculation for the Saturn V. The propellant mass for a single stage launch vehicle is given by this equation. So we have propellant mass on the left, and we have payload mass on the right, and we have a bunch of other stuff, such as, this is the delta V of the propulsion system. We have an exponential. We have the ISP and gravity. That is the standard gravitational acceleration for free fall, G. And we have something called the inertial mass fraction. That's basically telling you how much structure mass you have compared to a structure mass plus propellant. And on the bottom we have 1 minus the F inert times this exponent. And this is also in SPAD on page 15, equation 1.27. Now before we put a lot of numbers in here, let's just look at what happens downstairs. Okay, this is the denominator. Whenever you have, 1 minus x, over something, you have to be careful that x never becomes 1, because then you would have 1 over 0, and that would imply that you would need an infinite amount of propellant. So if we're using a formula like this, we should make sure that this number downstairs is not 0. We also should make sure that it's not negative, because if it's negative, in some sense, it's even worse, okay? There's no such thing as negative propellant. And so you might wonder, well, what does that mean? Well, it's important, that engineers must interpret their equations. Okay? What do the equations mean? What are they telling us? Are they telling us something that's logical or not? Are the equations not relevant for this particular problem, or are the equations telling us that something's breaking down? These are important issues whenever you make math models to solve problems. Now this equation is telling us something that's actually true. It means that if downstairs we have a 0 or a negative number, it means that the launch vehicle you're trying to design is infeasible. Okay, so it's and how can we check that before we go into details of calculating equation 4? Well, if we look at the denominator and set this to 0, and notice, by the way, as ISP gets larger, as ISP gets smaller, I should say, if it's a small value, this exponential term will become a bigger number, and that'll get you to a negative value quicker as ISP goes small. So if we set this equation to 0, we get that the ISP is equal to delta V over the log of 1 over F inert times G. And if ISP is less than that value, then we have equality means the propellant is infinite, and less than the less than sign implies that the propellant is negative. Okay, so these are both infeasible conditions. So this is something you should check before you go any further with these complicated equations. The first stage of the Saturn V used kerosene and liquid oxygen for propellant with an ISP of 264 seconds. And the value of this inert mass fraction usually ranges from 0.05 to 0.1. In other words, about 5% to 10% of the mass of the propellant plus structure is structure, basically the tank and other stuff holding things together. In fact, 5% is a pretty small value. It's hard to achieve, but we'll assume that optimistically just to do a calculation with the Saturn V. And notice that the G, whenever you're using the G in these propellant, this exact value of 9.80665 meters per second. It's a defined quantity, and there's no number after the 5. This is exactly what the value is. And that should be used in all of your propellant mass calculations. Now, if we plug into our equation that the delta V required of the propulsion system was 9,267 meters per second, and that was what we had in the budget that we showed earlier, and putting in our other values into the infeasible test, we obtain the following. ISP, is the ISP less than this value? We have 9,267 meters per second upstairs. The logarithm of, this is the natural logarithm, by the way, of 1 over 0.05 and then times the standard free fall g. And we get a number of 315 seconds, but we had used 264, which is smaller than 315, so we have an infeasible case or a non-feasible condition as it's stated in SPAD. How do we fix this? Well, possible solutions are improve the ISP, use a bigger value for the specific impulse, reduce the inert mass fraction to even less than 5%, or use staging. So instead of one stage, use two. Or say 3 stages. The Saturn V used 3 stages and higher ISP by using hydrogen, and liquid oxygen in the second and third stages, and had a value of F inert that was a little bit bigger than 0.05. As I said, that was an optimistic value. So that concludes our discussion on the delta V budget.